The third question in projection of solids is a square pyramid, side of base 50 mm and height 80 millimeter, rest on one of its base corner on VP. So this word rest is an indication that it is the first stage. To rest on one of its base corner on VP. The apex of the pyramid is 75 millimeter in front of VP and the axis makes an angle of 30 degrees HP. Draw its projection when apex is near to HP. So as we have discussed that the resting condition is always the first stage. So it's clear that rest on one of its base corner on VP. So this is our first stage, rest on one of its base corner on VP. If the first stage is with respect to VP, the second should be compulsory with respect to VP only. So the apex of the pyramid is 75 mm in front of VP is the second stage. And last is the axis makes an angle of 30 HP and also apex near or apex away is satisfying the third stage. So VP HP is the condition for this question. So we will write down the first stage over here, stage 1. Stage 1. Okay, so as it is being told that pyramid rests on one of its base corner on VP. So it's given that one base corner on VP. This is our first stage, and we know that forcefully we need to make the entire base to rest on VP. Okay, so this condition has been given, but we need to satisfy what is written in the bracket. Now you can very well see that the first stage is with respect to VP. The second should also be with respect to VP only. Okay, so reading the question further once again, it's given that the apex of the pyramid is 75 millimeter in front of VP. So we write down stage number 2 over here. So stage 2, apex of pyramid is 75 millimeter in front of VP. That is the second stage. And finally stage number 3, stage 3. So it is not compulsory to write down the stages in the examination. You can directly start with your answers. So finally what they have said is after VP and VP, the third condition should be with HP. So they are saying the axis makes an angle of 30 with HP and apex near to HP. Okay, so axis makes 30 degree with HP and apex near to HP So first we will start with a medium dark XY line. I'll align the scale, roll back, and approximately in the center I will draw one medium dark XY line. So now this is parallel to the paper. Let us align the scale with that line and we'll extend the line further to draw medium dark XY line. So we'll write X and Y over here. Okay. So now let us start with the first stage. It's written here, one base corner on VP. So you need to be clear that this is a square pyramid. So you want one base corner on VP. Suppose this plane is VP. Okay, this plane is VP and you're looking in the front, for example. So what we need is the right side should be a corner, because in the next stage when you tilt, the corner should rest. By mistake, if you draw the square like this and the right side is the base edge, and if you then tilt, the base edge will rest on VP. So if you want a corner to rest on VP, right side should be a corner, plus the diagonal passing through the corner should be parallel with XY also. So if you try to visualize in 3D, so the diagram will be like this here. So this is a square pyramid, for example. So let us try to draw a square pyramid. So So I'll try to draw a square pyramid resting on VP. Okay, so this is the square pyramid. Suppose this corner is A, here you have B, C and D, and this is the axis over here. Okay, so just erase it. So here this is the vertical plane and this is the horizontal plane. So this apex is O and this point is M. So now when you look in the front view from this side, you can see a square with right side as corner A. And when you look in the top view, the projection of all these base edges, it falls on XY. You'll get a dark line here. And one more thing to be understood from the top view is you can see a slant edge and two triangular face on either side. So you can see a slant edge. So when you project O, the slant edge apex will be here and you can see two triangular faces. Okay, you can see two triangular faces like this. So on the projection of B and D will lie in the center. A will be here, C will be here and O is on this side. So this dimension what is given the question is, this is 80 millimeter. So the axis is 80 millimeter long and this dimension is 50 each. So the square base edge is 50 and axis is 80 millimeter. So in the top view, one important thing to be understood is the slant edge OD overlaps with the axis OM. So slant edge is always an object line which is dark and axis is medium dark. So preference should be given to object line. Hence you have to draw object line here and not the axis. So but axis and this overlap. So M will be in the center. Okay, so further when you turn HP down, so this is your horizontal plane. When we turn HP down, we know that the HP when it moves down, this triangle will also move along with it and you're going to get the hanging triangle. So the triangle will be upside down after you turn this out. So we need to start with the front view where you have to draw a square which is inclined with respect to horizontal on both the sides so that you'll get a corner. So let us now learn how to draw a square. Okay, so this is our XY line. We need to draw a square with edges inclined on both the sides. So see, when we draw a square, for example, a square can be drawn with two positions. So first you can draw a normal square of side 50 outside by scale and join the diagonal. Correct? Step number 2, what one can do is on this side you can draw two light lines and by compass, so you have to draw this to scale. So by compass take half the diagonal and from this point cut up, down, right, left and join all the points. You'll get a square like this. So this is one option. Second option to draw the square is, see this both the sides are inclined at 45 degree to each. So if you don't want to spend time in drawing the square outside, the second option is you draw two lines at 45 degree and mark 50 on them and then continue with drawing the square. We'll follow method number 2. So what one can do is you can align with the XY line, slide up, draw a light line, okay, mark a point arbitrarily and keep your protractor at that point and we'll mark 45 degree with respect to horizontal from both the sides. Okay, and with scale we will join that 45 degree with the arbitrary point what that you marked before. So draw two lines light. So in the question the side of the square what is given is 50 mm. Okay, so we have drawn two lines at 45 degrees so that you'll get a corner on the right side. Now we can set 50 in the compass. So I will set 50, 5 in the compass. And with this point I'll cut on left and right, and with the new point I'll cut two arcs on the opposite sides. So that is how I get a square resting with a corner on the right side, okay, over here. So we can draw this dark directly. Yeah, apart from this, the diagonals needs to be drawn dark. So from here to here, this diagonal will be dark. Okay, so this part is being done. We can erase the unwanted lines if it is dark. So to avoid confusion, we'll erase some of the lines which are dark or medium dark. Light lines can be retained, no problem. Now, as we discussed before also, when we start naming, always start from the right side. This is A dash, B dash, C dash, D dash, and here it is O dash and M dash both. So why we have drawn the square above? Because it's given one base corner on VP. So we need to follow this practice of keeping the entire base on VP. So when you make a base of a solid to rest on VP, it is like a wall clock, and the true shape of the wall clock can be seen from the front view. So we are drawing above. Okay, so that point is clear to all. So we have marked A dash over here. We need to show dimensions at two adjacent sides of a square. So whenever you draw a square, you need to show dimensions of the sides at two places. Okay, so here, so draw medium dark extension lines and then show dimension line at both the places. Okay, with standard arrow marks, thin and long, and write 50 above the line. So the 50 is over here. This is called above the line, and here above is on this side. So you need to write 50 like this. Okay, now second diagram, observe looking from above. So you can see everything within 180. So you can see three slant edge, OD, OA and OC. So let us draw the next view. So when I draw the top view, okay, as we have discussed that in the top view what happens, you can see a hanging triangle in the downward direction. So when you turn HP down, this portion has to come down. So you can visualize like this. So this HP will go down. So triangle will also fall in the downward direction. It will be downward like this. So let us project all the points. So first I will project the mid one. Okay, so let us project this one first. I will extend this here, project A till X5, and we'll project back, we'll move back. And then we'll project C here. So once this is done, this point will be A. Center you'll get B and D. This point is C. Axis side given the question is 80. So we can mark 80 from here directly by scale. We can mark 80 directly. This point will be our point O. Now in the top view, we can see three slant edge. Let us start one by one. You can see slant edge OC. So see O is here and C is here. This can be drawn dark. So we have drawn that dark. We can see slant edge OA. So even OA can be shown dark. Next we can see slant edge OD. See OD is in the center. Do not forget to show the base dark. Okay, now what we cannot see from the top view is the slant edge OB, because that is beyond 180, and coincidentally it overlaps with OD. So if you look at the square pyramid, okay, and if you look in the top view like this, so this is the top view, you can see three slant edge, the fourth one will overlap. Also you can see these two black lines, this line and this line is a base edge. It is seen as a continuous line in the top view. So therefore this line is continuous. Again, as we discussed before, the axis overlaps with the slant edge. So we need to draw a perpendicular sign inside and write M inside. To complete the answer, with all respect, we need to show dimension 80. So here we need to extend this down from O, draw medium dark line, and 80 we need to show 80 mm. So this dimension is 80. So now in an illogical way, the third diagram to be drawn is first, second, third has to be down. Down means top view. But we need to see and understand what is the logical way. So here is written apex of the pyramid is 75 millimeter in front of VP. So you need to understand what is apex. Is it a line or a point? So you can make out from the first diagram. See, this is the apex O, right? So now apex is a point. So if a point is in front of VP by some distance, for example, so in the first stage it is in front by 80 mm, isn't it? So this in front distance, that is 80 mm, can you make out from front view or top view? That is the question. So if you look in the front view, you cannot make out whether this is 80 or not. You cannot make out. But in the top view you can make out whether this is 80 or not. So anything in front of VP can be seen from the top view. And as per this question, it's written apex of the pyramid is 75 in front of VP. So apex is a point, and point in front of VP can be seen only from the top view, and therefore we have to start with top view. This is the logical answer why we have to draw in the top view. Okay, so here we have a pyramid resting on VP on one of its corners. Let us see. So when a pyramid rests on VP on one of its corners, what we do in the first stage is we make the entire base to rest on VP, as you can see here. And when you look in the front view, exactly, you can see a square, you can see all the four base edges, and also there is a corner on the right side. See, right side, this is the resting corner. But when you look in the front view, you cannot make out how much is this apex is in front of VP. Yeah, this is the apex here, but how much it is in front, we cannot make out from here. And this square has to be drawn above XY because the diagram should not touch XY. They have not mentioned that this corner is also on HP. It's not mentioned. So you have to keep it little above. Okay, so this is the first stage front view. What you can see it as a square. So whenever a base corner or base edge rests on VP, what you should do is you should make the entire pyramid to rest on VP first. Okay, so the entire pyramid should rest on VP. But corner should be on the right side. Now slowly we'll go into top view and see the fundamentals. So in the top view, what you observe is you can see that in the top view you can see two triangular face, right and left. You can see two triangular face, and in the center you'll find one slant edge. Correct. So now in the top view you can make out that how much is this apex in front of VP. So that is what I was saying, that always in front of VP condition can be seen from the top view only. So this is the second stage top view where VP is seen as a line. So see, VP is seen as an XY line. This is the XY line. Okay, if you look perfectly from here, so this is the XY line, and this is the square pyramid, and you can easily make out that apex is 80 in front. So in front is nothing but the top view condition. Okay, and you can see only two triangular face. The axis will overlap with this slant edge. So let us see the second stage now. So this was the first stage where the entire base was resting on VP, and the right side you had a corner. So in the first stage, this apex, if you extend this apex, it is 80 millimeter in front of VP. Okay, so this is a vertical plane, as you can read here. So apex was 80 in front of VP. Now in the second stage, what you have to do is that, to all of you remember that when you draw the second stage, you should carry forward the first stage condition along with you. So this right side corner should be on VP, and this apex should be 75 in front. Right now it is 80. How will you make it 75? That is the question. So what you'll be doing is, the right side corner you'll keep on XY and you will tilt the pyramid. So you have to tilt such that you have to tilt unless, now see, if you now see this apex, the distance is reduced from VP because initially this distance was greater, it was 80. So the moment you start tilting, one point will remain on VP, and this apex, the locus of this apex will be 75 in front. Initially it was 80, now it is 75. See, the moment you tilt, the distance goes on decreasing. So that is the condition, the second stage. What you have to do is that, if you look in a top view perfectly, the entire base was resting in the first stage. Now tilt, only the corner should rest, and the apex distance should be 75 in front. If you carefully observe, from the top view, the outer shape of the triangle, it remains same, it doesn't change. Only the orientation of the triangle has been changed. So you have to tilt like this. Unless the apex is 75 in front, and that you can see only from the top view. So first, second and the third diagram, this triangle you need to tilt. So this triangle you have to hold in hand and tilt such that corner A should be on xy and the distance of O from xy should be 75, because this is our VP and this is our HP. So I want this apex 75 in front. Right now this is 80. We need 75 in front. So tilt the pyramid. Okay. So this is the pyramid. So tilt such that the apex is 75 in front. So our standard method to draw the second stage is what, always mark that point first which you need on xy. So we need A on xy. So you have to mark point A first. Randomly you have to mark point A. Now we need point O 75 in front. So we can draw a locus of O which is 75 in front. So let me mark a point 75 first. So this is 75, and parallel to xy line we can roll this down and draw a light line. This is the locus of O. So point O should lie here. So see, we are tilting in this direction, right? So I think we have to mark a little bit here. So I'll erase this A. Okay, now O should lie on this locus. So we'll extend a bit. Okay, so as the shape and size of this triangle will not change, and because O should lie here, we can take A to O in the compass. So the size of the triangle should remain the same. So let us take A to O in the compass. So I will take O to A in the compass like this. And from this point A, now see, you have to decide right or left. So because this is going to tilt in this direction, O will be on the right of A. So this point is O. So copy paste the same diagram. A to O is dark. So connect A and O with a dark line. Double trace. Now after O is done, what you should do is you should first focus on the outer triangle. For the outer triangle, you have point A, you have point O. So we can obtain C using arc method. So what you should do, because we have line AO, you should take A to C and O to C in the compass and cut from A and O in this diagram. So see, let us take A to C first. So we are using arc method. So A to C is there with us. From A, draw a light arc. So C will lie on this arc. Then from O to C, take O to C in the compass. And from O, cut the opposite arc. So wherever both the arcs intersect, that is our required point C. Okay, so we can join these 3 points to get the outer triangle. Now once the outer triangle is ready, we can take the distance C to BD in the compass. So let us take C to BD in the compass. And from C, we will cut here. So this point is B as well as D both. So this point is BD. Join BD with O. Okay. Also mark point M which is inside. So that is how we have satisfied the second stage. So very simple. As we discussed, when you read the second stage, you should read both the conditions together. So one base corner on VP and apex of pyramid 75 in front of VP. See how it is satisfied. You can see one base corner on VP, because in top view XY is your VP. So one base corner is resting on VP, plus this apex is 75 in front of VP. Okay, this apex is 75 in front of VP. So that is how the second stage is satisfied. So we need to show dimension 75 here. So here a vertical extension line should be drawn and write 75 on this side. So this is 75. So that is how this diagram is ready. Now look at this diagram from this side. You can see everything within 180. So O to C can be seen. You cannot see what is beyond. So in one glance you should be able to decide, when you draw the next diagram, the base will be hidden. So because you can see from O to C, you cannot see this base ABCD. Correct? One more way to look at this, if you compare O with M, O is near, M is away, and M represents the base. So because M is away, entire base is away, so the base has to be drawn hidden later on. So what is our first job? Project all these points up and project square from this side. The combination will give you the fourth diagram. So to start with, we'll align this with this vertical line. Then from C we will project all the points above C, then comes BD. Okay, so let's see it is aligned properly. C, BD, then comes A, and finally comes O. So I projected all the points up. I'll extend it somewhat above. Okay, now this square we need to project from here. So aligning this with XY line, first I will project B, then this one I'll project here, and then D. Okay, so now let us name the various points. So starting from here, this point is A, and here A is over here. See, combination of both will give you A dash. Front view means dash. Then B is over here, and corresponding B is on this side. So this is B dash. Then C on both the sides, C dash. And D in the center will give you D dash. So you have to look from both the sides. And one simple thing to notice, see, ABCD is in a clockwise manner. So the same square has been compressed now. The same square has been compressed in size. So it is A dash, B dash, C dash, D dash like this. From point O, you have to mark O dash over here. So this is your O dash. Now step number 1, the shadow of any object is always dark and never hidden. So we need to darken the outermost points. So say I have joined the outermost points with dark line. Step number 2, looking from this side, compare O with M. Because M is away, base is away, so base has to be shown hidden. Also, if you switch on the bulb and emit parallel rays of light, you can see from O to C everything, because that is within 180. You cannot see what is beyond, so automatically base will be hidden. So out of ABCD, the lines which are left out should be drawn hidden. So A dash to B dash will be hidden. So we need to draw a hidden line here. Okay. Next, you need to join A dash with D dash. Even this is hidden. Okay, so the base is being done. So first outline, then the base. Third step, very simple. From dark corner of the base edge, from the dark corner of the base, draw dark slant edge. So a square pyramid should have 4 slant edge. We have drawn 2, O to D and O to B. 2 are left, O to A and O to C. So from dark corner of the base, draw dark slant edge, and dotted corner of the base, draw dotted slant edge. So if you look at A dash, it is a dotted corner, so you have to draw dotted slant edge towards O dash. And C is a dark corner, so draw dark slant edge towards O dash. So they will overlap. So should we draw hidden here or dark here? So very simple, you have to draw dark because that comes first. How will you understand? Look at this diagram. So look from this side. Compare OC and OA. Because you can see within 180, OC will be dark. So let us draw OC dark. Okay, now you cannot see OA from this side because it is beyond 180. So there is no point in drawing hidden line now because it overlaps. So what comes first from here? This is the observer. So first comes OC. So we have to draw that. Finally, this point M, when you project from both the sides, the intersection you have to mark a cross sign and write M dash. So even the axis is overlapping with the slanted OC. Okay. So what is happening is, look at this square in the first stage. This is the front view. So I have kept a pyramid here. So the right side is OA, the left side is OC. In the second stage, what you're doing is you're tilting the pyramid. So see, remember this is OA and this is OC. So when you tilt the pyramid like this, you can see what? You can see the slant edge OC. So see, this was OC, which was a smaller length initially, but when you turn, OC will be seen clearly. So OC is seen first. You cannot see OA because OA goes on the other side after you tilt. Therefore, it is behind OC. And even the axis overlaps. So after we are done with the 4 diagrams, first, second, third, fourth, fifth has to be here besides fourth, and it should be a reproduction of this. So the same diagram you have to reproduce. So let us read the question. What does it say? axis makes 30 with HP and apex near to HP. So what student do is that in this diagram, where is the axis? It is O2M. So this O2M which is right now parallel with HP. So why I call this as HP? Because in front, for front view, XY is HP. So you want this OM at 30 with HP, that is what is said. So the line OM should be 30 with HP plus the apex should be near to HP. So you need to tilt this down such that O should be near to XY and line OM should be at 30 degree. That is what is interpreted by the students. But there is a small change. What is that? Let us see. See, axis means it is a line. And if you go back to the lines chapter, when I say line makes 30 with HP, it means true length of the line makes 30 and not front view or top view of the line. But instead of axis, if I mention front view of the axis makes 30 with HP, that is a different story. So there are two types of question what can be asked in the third stage. Number one, only axis makes 30 with HP. Second, front view of the axis makes 30 with HP. So let us see what is the difference first of all. So go back to this diagram. So in the question, axis length was 80 mm. So you can see that O2M, this was the axis, and if you measure, we have taken this as 80. See, we have taken this as 80. Correct? So this is the true length of axis. I'll write TL over here. So TL means true length of axis. So you can write in full true length of axis. Now when you tilt this diagram in the second stage, is this still the true length or is it reduced? So because I told you the shape and size remain same, so this is still our true length. So if you check this dimension, oh, it is still 80. So this is nothing but true length of axis. This is nothing but true length of axis. Now, important thing, when you project this O and M, and if you look at this front view, this length O2M, is it still 80 or less? So let us keep our scale here. It is somewhere around 64. So this true length which was 80 in this diagram, or in the top view it was 80, when you project it has become apparent. So the length O dash to M dash is called as FV, means front view of axis. Okay, so what is the big deal in this? So the question says they want the true length of the axis, because they have said only axis. They have not mentioned front view of the axis, they have said only axis. So they want axis at 30 with HP. It means it is clearly mentioned that they need true length of the axis at 30 degree. So if you tilt this diagram, what is going to happen is you are going to make the front view of the axis at 30 degree, which is incorrect. Okay, so what can be done? So in a nutshell, it will not be correct to tilt this front view of the axis at 30 degree. That is what I want to say. Because at 30 degree, the true length of the axis must lie. So what needs to be done is, outside you need to take one arbitrary point on XY, mark 30 degree, as you can see here. From this arbitrary point, you have to mark 30 degree. So that is how I drawn a 30 degree line. So this is at 30 degree. So it's mentioned in the question, on this 30 degree, you need to mark true length of the axis, and true length of the axis is 80 millimeter. So I will take this 80 in the compass. So what we are doing is we are applying the concept of lines. See, just observe what we are doing. So on this 30 degree, as per the question, you have to mark true length. So I mark true length over here. Now see, what is the name of the line? It is axis, means OM, right? So this is O dash and this is M dash, M1 dash. Why? Because recollect lines. In lines, when you used to mark true length, it used to be A dash B1 dash or A B2. So because this is in the front view, it is O dash M1 dash. So you mark 30 degree. Now recollect that in lines, after you mark A dash B1 dash, we used to draw locus of B dash. Same procedure here also. From M1 dash, we will draw locus of M dash. No need to write locus of M dash. So on this locus of M dash, one more point should lie, that is M dash, and O dash M dash is nothing but front view of the line. And this length from O dash to M dash, this is our front view. So now you can take front view in the compass, and from O dash, okay, from O dash you can cut an arc on this locus. But because this is not a lines chapter, you need not draw this dark. So you have to draw this light for your reference. So this is our front view length, O dash M dash. So what we are trying to do is, we know that front view with xy is alpha, so we are trying to find this angle alpha, that's all. So if you measure alpha, how much it is? Okay, it is coming around 39 degree, 38 or 39 degree. So alpha is around 38 degree. Okay, so this alpha is 38 degree. So what we've done in short is, instead of drawing true length of the axis at 30 degree, we can draw front view of axis at alpha, that is 38 degrees. Okay, that is 38 degrees. So both are equivalent, that you can make out from here. So concluding this new fundamental, I would like to say that whenever in the third stage true length of the axis makes 30 with HP is asked, you need to find out then what will be the front view of the axis be inclined at. So you need to find that angle by the concept of lines. But sometimes in the last stage they will directly mention that front view of the axis makes 30 with HP. Then directly you need to tilt this O dash M dash front view at 30 degree, nothing to worry. Okay, so these are the two concepts what I wanted to highlight. Now this part can be erased. Once you found the angle, you can erase this part if it interferes in your way, or if you drawn this somewhere above, somewhere at a place which is in between, then you can retain this. Okay, so alpha you found, now you can erase this part because it's going to interfere, or you can draw somewhere in the next page also. But in the exam what you should do is, if you have sufficient space and if you have drawn this somewhere besides, it is okay. So now because we know the apparent inclination of front view of the axis is alpha, that is 38 degree, and they also said that apex is near to HP. So we need to tilt this diagram such that apex should be near to xy, but it should not intersect xy. Otherwise they should have written that apex on HP. So they are not mentioned like that. So let us mark a point arbitrarily little bit away from here. That point is O, because I am going to tilt this downward. So this is O dash. Okay, from O dash, now see the tilting direction is towards left side. So from O dash we need to draw a line at 38 degree and not 30 degree. So the moment you draw 30 degree, couple of marks will be deducted. So here let me keep the protractor here, and with left side horizontal I will mark 38 degree. Okay, and we are going to draw a light line. So see, this is 38 degree, right? So this angle is alpha, 38 degree. Now on this O dash, point M dash should lie. Now by looking at the geometry, not only M dash, from O dash if you observe on this line, A dash, M dash and C dash, these 3 points lie. So those 3 points should lie on this line now. So we will take O dash to A dash in the compass, and from O dash we will cut an arc here. Then we will take O dash to M dash in the compass, and from O dash we will cut one more arc here, and last is O dash to C dash. This is our third arc. Okay, so let us name those points. So this point, which is the first one, comparison, it is A dash. So on comparing you will find this as M dash and this as C dash. Now I need to mark B and D. So instead of using arc method, which is inaccurate, you have to use perpendicular method. So look at this line carefully. Line B dash D dash is perpendicular with OC. Okay, and it passes through M dash. So B dash D dash, this light line is perpendicular with OC and passes through M dash. So I need to draw a line passing through M dash and perpendicular to OC. Okay, so just align the scale unless one of the calibrations is in line with line OC, as you can see here, and draw a light line. Then you can take M dash to D dash in the compass, Okay, and now logically both should be same, right? So here from M dash, cut up and down. You have to cut up and down and name this point as, one point is D dash, another point is B dash. So you have to reproduce the same diagram. That is our final objective. So from O dash, join with D dash, dark. From O dash, join with B dash, dark. Join with C dash, and finally with D dash. Next, these hidden lines need to be copied as it is. So D dash to A dash is hidden. And A to B is also hidden. Finally join O dash with C dash. Okay, so see that nothing is left out. Yeah, everything is done. So with horizontal, with this horizontal, we just need to mention that this is the apparent inclination at 30 degrees. So you can write alpha is equal to 38 degree. You can show in the exam like this. And you can write down here, this is FV of axis. So by this it will be clear to the examiner that you have not taken 30 degree, but it is 38. Now once this diagram is over, you need to draw the next view. So observer is looking from above, isn't it? So from above, you can see point M dash clearly. You can see point M dash very clearly. So base, so if you compare O with M from above, M is near, O is away. So base will be seen. So let us project all these points in the last diagram over here. So I'll align this with O dash, and first comes B, then comes C, A and D, then finally O. Okay, now from this side, parallel to the XY line, after A we can project B and D here. Okay, let me take it the reverse way. Then we can project C, then we can project this O. Let us extend this O a bit on this side. So if you look at the combination of both these diagrams, so starting with A dash, so the projector of A dash is here and corresponding A is on XY. So this is point A. Then B dash is here, another B is on this side, this is B. So to go in sequence, C dash is here and next C is on this side. D dash is here and D is over here. O dash and O. So this point is O. So we have named all the points. Next step, join the outermost points with dark line. So we will join A and B first. Then we will join B with C. C with O. Now you should not be confused whether to join O with D or O with A. So align the scale. So see, O, D and A are not in the same line. So O to A can be joined as the outermost. So D will lie inside the shadow. Correct. So that is how it is. So now look from the top view. Compare O with M. So from here M is near. It means the base is near. So in the next view, base should be drawn dark. Also, if you want to look from another point of view, switch on the bulb from here. So you can see everything from B. See, B, C and B comparison, B is the outermost. So from B you can see everything, and here O is the outermost. So B to O everything can be seen. That covers the base also. So here out of A, B, C, D in sequence, you should join A to B, B to C, C to D dark, and D should be connected with A dark. The moment you see a dark base, you need to understand, or you need it should click that whenever a base is dark, it becomes a no entry area. So from this no entry area, a dark line should not pass. A dark slant edge should not pass within the base. Now next step is, in case of square pyramid, there should be 4 slant edge. You have drawn only 2, O to A and O to C. two more are left, O2D and O2B. So from dark corner of the base, draw dark slant edge. So D can be connected with O. But B is also a dark corner. We can't draw dark slant edge because a dark line cannot pass through a visible base. Also, two dark lines should not cross each other. So from B to O, we have to show hidden. So we'll draw this hidden. Now one more thing, let us verify why this is hidden. So if you look at O to B from the top view, you can see from B dash to O dash everything. You cannot see this slant edge OB from top, and therefore it is hidden. In the top view, if you look from this side within 180, you can see slant edge OD, so therefore OD is dark. Finally, don't forget to draw the axis here. So we need to project point M. So from here, we will project point M dash from here. Okay, and also M from this side. So that is already projected. So the intersection of M dash with this M, mark a cross sign and write M. Join O to M with a center line to represent the axis. So finally what is happening is, look at this diagram. You will find that one corner is on VP. Why I am calling VP? Because this is the top view, and for top view XY is VP. So how did you get this corner on VP? Because you started like that. So the first stage and last stage are related. Okay, so very simple. If you want a corner on VP in the last stage, you should start with the corner on the right side. So they are related. Apex is 75 in front of VP. So look at the last stage. Whenever a point is in front of VP, you should be very clear that it is seen from the top view. So look in the top view. This is the apex O, which is 75 in front. No need to measure because you have projected the same O. So automatically this will also be 75. And finally, front view of the axis should make an angle. So they want axis at 30 degree, true length of the axis. It means front view should be at 38 degree. That is what it is. Okay. So let us see in the model, how come in the top view base is visible. So this was our first stage where right side is a corner. In the second stage, I made the right side corner to rest on VP, and apex is 75 in front of VP. What you can see from the top view, apex is 75 in front of VP. Now what we have done in the third stage is, in the third stage I want apex near to HP. So if I tilt like this in the third stage, it is incorrect. This becomes apex away from HP. If you want near to HP, you have to tilt it down, isn't it? But it should not contact HP. Now if you look in the top view, some portion of the white base can be seen. So very simple. This was the first stage, top view. This was the second stage, top view. And when you now tilt and make the apex near to HP, you can see the base from the top view. Opposite, if the apex is away from HP, you cannot see the base. Okay, so by this, all the three views are over.